Hey guys, today we're going to talk about Venus for a little while. First thing we have to know about Venus is actually Earth's sister planet. So Venus, the reason she's named Venus is because Venus is the Roman name for the goddess Aphrodite. You're probably more familiar with her, but she's the goddess of beauty, love, and from the Earth, when you're looking at Venus, it's just very beautiful to see, especially in the early night, right as the sun sets. It's very pretty. And so, because of her, that planet Venus looking pretty at nighttime, they named it Venus. But we're going to see later on in our notes that it's actually not very pretty at all when you get up close to Venus because of the harsh environment that exists on Venus. But it is Earth's sister planet. And the reason it's Earth's sister planet is because it's very, very close in size and composition and density as well. So the diameter of Venus is 9/10 the size of the Earth. 9/10. So it's very, very close to being the same size as planet Earth. And then I'll go and tell you some facts about it. The distance away from the sun, it's 0.72 AUs. The mass is very close to the Earth as well. It's 4/5. And then the density is actually 5.25 grams per centimeter cubed. So because of those reasons, that's why Venus is called Earth's sister planet. So this is actually what Venus looks like when you get up close to it. I always remember Venus because if you look here, it kind of looks like a boomerang, almost like a V. So this V shape here, V for Venus. So Venus, it's very dingy yellow and brown. The reason for that is its atmosphere. It's got a very thick atmosphere of sulfuric acid clouds, and you can't see the surface of Venus at all. The entire thing is covered with a really, really, really thick atmosphere. We'll talk more about the atmosphere later on. But that's what Venus looks like when you get up close. So Venus does go through phases like our moon, just like Mercury did, and it is a morning and evening star, just like Mercury as well. Mercury and Venus are both called morning and evening stars because you see them either directly after sunset or directly before sunrise. And they're always going to be very, very close to the sun. In our last section of notes, I told you that Mercury is no more than 28 degrees away from the sun, and Venus is at no more than 47 degrees away from the sun at all times. So the semi-major axis of Venus, that's the distance on average from the sun to Venus. We said that's 0.72 AUs. We said the Earth's semi-major axis would be 1 AU. Venus does have a very circular orbit. There is a little bit of an ellipse, but not much of one. It's very circular. And its orbital period, the time it takes to go around the sun once, is 225 days. Now, that Venus is a unique planet because a day on Venus is actually longer, a sidereal day on Venus is actually longer than a year. We're going to talk about why that is in just a second here. Now, this picture you see, this is a Venus. This is an infrared picture. So infrared shows you the energy of heat. And so it's really, really hot on Venus. Venus is actually the hottest planet in the solar system. It's 735 Kelvin on average, which is really, really, really hot. So these white areas you see, though, that's really, really hot. Probably running lava, lots of molten surface. We'll talk about surface features later on as well, but this is an infrared image. It's really the only way we can see Venus. I'll talk about probes that have landed on Venus later on in this lecture, in this PowerPoint. And I'll show you a couple images that we actually have of the surface, but most of the images we have are infrared because of that thick cloud layer. So we said Venus is closest in size and composition. Again, size, diameter-wise, 9/10 that of the Earth. Composition, its mass is 4/5 that of the Earth's, and its density is 5.25 grams per centimeter cubed. So it's a lot like the Earth, but it's a lot different as well. There's the density, and then the axis tilt. So Venus's axis tilt is 178 degrees. So if you think about that number for a minute, you realize that it's tipped completely over. So a lot of people always ask, well, why don't we just say the axis tilt is 2 degrees? Well, if you remember the right hand rule, so what you do is you put your right hand out and you put your thumb up. And what you do is you take your right hand and you twist, you turn your knuckles in the direction the planet is rotating, and then you put your thumb up or down in this case. So whichever direction your thumb is, that is the direction of north. And Venus is actually rotating backwards. So it's completely tipped over 178 degrees, which makes it rotate very, very, very slowly. And it also does not have moons. So Mercury didn't have moons. Venus doesn't have moons. The Earth will be the first planet with moons, which we've already talked about with Luna. So a sidereal day on Venus is 243 days. That's how long it takes for Venus to rotate once 360 degrees. One solar day on Venus is 117 Earth days. So a solar day is shorter in this case than a sidereal day because it is actually rotating backwards. So this shows you, I'll show you in the next slide, what it looks like as it rotates backwards. But so it is really the only planet to technically have completely backwards rotation. Later on, when we talk about the outer planets, we'll talk about one more. I don't want to tell you about it now. But it kind of rotates near on its side, but some people consider that retrograde. But Venus is really the only true planet that is basically rotating completely backwards with a rotation of 243 days backwards. So the way I'll indicate that on a test, I would say negative 243 days. Negative just means it's going backwards. It doesn't mean that time is actually decreasing. It just means negative just indicates backwards. So 243 days going backwards. So here, if you look, right here we have Venus. The arrow's facing the sun, and it is still orbiting counterclockwise. All planets orbit counterclockwise. Every planet in our solar system is going to go around the sun counterclockwise. Nothing is going to go clockwise. All the planets are going counterclockwise. And Venus is actually going to orbit, to rotate though. Instead of it rotating counterclockwise, it is actually going to rotate clockwise. So it's going to rotate around like this as it orbits. And so after 117 days, it is back to facing the sun. So that is one solar day, but a sidereal day will take 243 total days. So long time. We said Venus is never more than 47 degrees away from the sun from the Earth. So we're on the Earth. When we're looking up at Venus, it's never more than 47 degrees away. That's why it's always seen at sunrise or sunset, and it's known as a morning or evening star. This just shows you right here, there's Venus. Here you can see the moon. So looks like the sun is either rising or setting here. So there's Venus. It's going to be very low in the sky as the sun sets, and it's never going to be out in the sky very long at nighttime after the sun sets because it's so close. This is how Venus moves around in the sky. You can see how it just goes up. Never gets that high. It's always going to stay pretty low in the sky and then come down. I like this picture of Venus because you can see the clouds of Venus very well. You can see, if you look carefully, you can see like there's a haze around Venus. So that's just to show you how nasty these clouds can be. Later on, we'll talk about what would happen if you actually were to go and try to visit Venus. It's extremely hard to do because those clouds are definitely so nasty. There's a thing called the runaway greenhouse effect. We talked about the greenhouse effect when we mentioned the Earth. We talked about the Earth. Venus has a runaway greenhouse effect, and because of that, it creates these very, very nasty conditions on Venus with these sulfuric acid clouds. So here's more of these facts. We've covered most of these already, but it is the closest in size and composition. It is the hottest planet. We said it is over 900 degrees Fahrenheit, but I want you to know it in Kelvin. So it's 735 degrees Kelvin. That's about 460 degrees Celsius. No moons. One day on Venus is 243 Earth days. That's a sidereal day. That's how long it takes for one rotation. 1 year, 224 days. And then it has a sulfuric acid atmosphere, which is very thick. So it's got a bunch of sulfuric acid clouds. The Venera probes, those are Russian probes. Those are the only probes that have ever landed on Venus. We'll talk more about those later on. But the longest, they did not last long at all. They lasted anywhere between a few minutes to maybe about an hour, and that's about it. But I'll show you some images that were taken, and we'll talk about those just in a little while. We said this is an infrared view of Venus. Venus is very, very, very active with volcanoes. So lots of activity. If you were to try to go to visit Venus, this is what would happen to you. So you can see our friend Kenny coming down here. And then, yeah, he's catching on fire. He's also, so he's going to melt. He's going to be caught on fire. He's also going to his skin is going to be dissolved from all the sulfuric acid on the way down as well. We'll talk about the pressure as well, though. So the pressure, the atmospheric pressure of Venus is 92 bars. Remember, the atmospheric pressure of the Earth is 1 bar. So on Venus, you have 92 bars at the surface. That's going to basically squeeze your internal organs, and you're not going to have a good time if you go visit Venus. So the surface temperature of Venus, between 460 and 480 degrees Celsius on average. And we said, again, that's 735 Kelvin. This is what the interior of Venus looks like. Looks a lot like the Earth. So again, it's 9/10 the size of the Earth. So it has the same kind of layers. It has iron, nickel core. You have a rocky mantle. Notice 2 cores here. And then you have a crust. We said Venus is covered with clouds. You cannot see the surface. These are the only views we have, except for those Venera probes that went and landed. But these are the only views we have. We also have radar maps. I'll talk about that in just a little bit as well. We have a probe. The U.S. sent a probe called the Magellan probe, and that gave us high-resolution radar maps, and we'll talk about those in just a little bit as well. So the atmospheric composition of Venus, it does have a very, very thick atmosphere, which is why it's the hottest planet in the solar system. Most of that atmosphere is carbon dioxide. So 96.5% of it is carbon dioxide and only has 3% nitrogen. So carbon dioxide is a greenhouse gas. We talked about that when we talked about the Earth. We talked about the greenhouse effect. And so with the runaway greenhouse effect, it makes Venus very, very hot with all that pressure. And that's why, 96.5% carbon dioxide, that is a lot in the atmosphere. Most of the carbon dioxide on the Earth is found inside of the rocks. Well, most of the carbon dioxide in Venus is found inside of the atmosphere. If you compare Earth's carbon dioxide with Venus's, we both have about the same amount of carbon dioxide. The difference is its location. So much more carbon dioxide in the atmosphere than on Earth's location, than Earth's atmosphere, but the total amount is right about the same because it's the same size, and again, that's why Venus is known as Earth's sister planet. So water on Venus, you're not going to find any liquid water. So where is all the water at? Well, all the water on Venus is in the form of vapor. There's very little water vapor actually in the atmosphere because it's too hot for water vapor. So much less water than on Earth. So where did all the water go? It's too hot. So the temperature on Venus is so hot that the water vapor, so water molecules will move high up in the atmosphere, and that solar radiation is going to break apart the water molecules. So the hydrogen will escape out into space, and then the oxygen will actually come down because it's heavier than the hydrogen. The oxygen will come down and become part of the surface rocks. So you're not going to find very much water vapor at all just because it is just too hot. This graph here, this shows you how quickly the surface pressure, the atmospheric pressure of Venus goes up. So this shows you bars here. So 1 bar, this is where the surface of the Earth would be. Surface atmospheric pressure of the Earth is 1 bar. The surface atmospheric pressure of Venus is over 92 bars of pressure. That is intense. That is a whole bunch. The reason being, the atmosphere traps so much radiation from the sun because it's so thick with all that carbon dioxide.